I welcome you all again to this physics session. I am Dr. Sumit Bhatnagar. I am a faculty at Prepaze. So today's session will be on forces. Okay. So last six sessions basically we were doing kinematics, and so from this session we'll start doing forces. All right. Before starting, I just want to quickly introduce to you to Prepaze. Okay. So Prepaze is an online platform where you can get knowledge and study your subject whichever you want at your own pace and at the comfort of at your home from tutors from like me from all over the world, okay, which are experts in their respective subjects. And so please do go and check their website and book a free trial class. All right, so let's start today's session. So let's do it. So forces, okay, let's do it. So basically forces comes under what we are going to study, the forces, the power, energy, all these things are basically comes under, we call a word dynamics. Okay, so dynamics, basics, all this is dynamics, forces, power, your work energy, everything is in dynamics. Okay, so what is a force? Let's start with that first. So when we define force, okay, so force is basically a basic definition of the force is it's a push, okay, or a push or a pull, which can which can cause objects to move or have an acceleration to start movement or speed up. Okay, to start movement or speed up. Okay, it's the basic definition of the forces we have. Okay, now what is the SI unit of force? It is newtons. Okay, SI unit is newtons, and obviously it's a vector quantity. Okay, it's a vector quantity. Both magnitude and directions are very important when you're defining. Okay, now there are different kind of forces are available. Okay, different categories I will say. Firstly, if we have first contact force. Okay, one is the contact forces, and the second is the non-contact forces. Non-contact forces. All right. So under your contact forces, basically what are contact forces? Force exerted due to the contact surface. Okay. Whenever there is a contact surface, basically the force exists. Okay. So we say the force exerted due to contact due to contact between bodies. Okay. That is a contact force. Okay. For example, what do we have over here is normal reaction force, normal reaction force. Okay. Then we have basically friction force, friction. Then we have tension. Okay. All these forces are basically an example of your contact forces. We will be studying each of these in detail a bit later. So then we have non-contact forces that act through vacuum. Okay, these act through vacuum basically. Act through vacuum. Okay. So for example, in this category, we have gravitational force, which is a weight, or electrostatic force. Okay. We have electrostatic forces and we have gravitational forces. All right, these are both examples of your non-contact forces. Okay, these two forces will be discussed in later chapters. Okay, right now this in forces we will not be discussing that. Okay, so let's study the contact forces a bit in detail. Okay, so when we say contact forces, basically there is firstly is the gravitational force. Gravitational forces. Okay, now we say this forces is a weight force also. This is a gravitation force or a weight force. Okay, what does this force? Basically, suppose let's say there is a ball or any object which is in air. Okay, there's a ball in air. Okay, so definitely there is weight. Why it is coming down? Why this ball, when you throw a ball or any object upwards, why does it come down? It is obviously, do you know the reason? It's due to the weight or the gravitational pull of the earth. Okay, that is the gravitation force. All right. Okay, similarly, suppose right now it was in air. If I keep this ball on an inclined surface like this, where the weight will be, it will be always downwards. So it does not depend where the body is. Okay, if we are talking on the earth or nearby earth, there is always a gravitation force which is always downwards. Clear? Okay, so that was about that. Now the direction of this, the sorry, yeah, the direction of this force is basically always vertically downwards. It is always vertically downwards. All right, always vertically downwards, and its magnitude is given by W equals to M into G. All right, where W is the weight, you know, M is the mass, and G is the gravitational acceleration due to gravity. Okay, so I'll just write for G. It is basically acceleration due to gravity. It is acceleration. If you don't know, it is acceleration due to gravity. Okay, which is basically G is equals to 9.8 meter per second square. Okay, and approximately we take it 10 also for some numericals. Okay, so that was basically about the gravitation forces. Okay, the next type of force which comes in this contact force category is the normal reaction force. Okay, this is also quite important when we are dealing with forces chapter. Okay, so the next category is the normal reaction force. Next type is normal reaction force. Okay, we represent it by Fn. Okay, sometimes depends. It is just N also, or it is Rn. Okay, so these are the all basically different forms you can be represented. Okay, so what is it exactly? So suppose let's say I have on the level ground. Okay, this is the ball which is kept over here. Okay, so the weight is W downwards, and there is a normal reaction force upwards. Okay, so now this is basically defined as a normal reaction force. Okay, but if I keep the same ball now on an inclined surface, okay, the normal reaction force will be like this. Weight will definitely will be downward only. Okay, so normal reaction force is always perpendicular to surface. That is very, very important. A lot of students make mistake. They make forces, normal reaction force always upward. It is not the case. It is always perpendicular to the contact surface. Okay, so I will just write the statement over here. So the direction is always perpendicular to contact surface. Okay, and the magnitude of this force is basically governed by, okay, we determine it according to Newton's law. Determine according to Newton's law. Okay, depends on what question we have and what surface we are dealing with. So the magnitude of the normal reaction is not fixed, like the weight, it is fixed. So it is basically a Newton's law basically we use to define the magnitude of that. Okay, so that was about basically the two forces, the gravitational force and the your normal. Okay, so after this normal reaction force, we have basically the next force, the next type of force, which is very, very important, I would say. Okay, it is the most extremely important among all the forces which we'll be discussing today is a frictional force. Okay, so third basically is the frictional force. Okay, okay, or the force of friction, we represent it by a small letter f. Okay, or we also say it f small f. Okay, depending. So mostly small f is used for the friction. Okay, now what is friction? That is the very important question. It basically opposes relative motion. Okay, it opposes relative motion. Okay, now what is a relative motion? That is a very important thing to understand. Okay, if you are not able to understand right now, it's okay, but I will uh, try my best to make you understand what does it mean to oppose a relative motion. Okay, now let us understand that. Suppose, let's say, imagine, okay, just take your hand. Okay, example, suppose in your hand, okay, suppose I just drew it to your hand. Okay, and there is a box which is kept on your hand. Okay, there is a person which is basically seeing you. Okay, another person which is seeing your hand. Okay, now if suppose I say that your hand is moving, when you're seeing your hand, okay, when you're seeing your hand, you're moving it right like this. You're moving forward, you're moving backward, you're moving your hand. Okay, the box, okay, the block over here, the box is moving with your hand, isn't it? You're moving it slowly. Okay, so the box is moving with your hand. Okay, so this person which is standing, this person sees that box is moving, isn't it? But to you, it is at rest. Okay, you are moving it very slowly, right? You're moving your hands very slowly, and there's something as something a box or something like this. Suppose this is one thing I kept in my hand. Okay, I'm moving my hand. Okay, so there is another person, let's say behind me here. Okay, he or she seeing that this black one which I kept my earpod, it is moving with my hands. Okay, but is it moving with respect to you? No, it is not moving with respect to you. Okay, for you, this was at rest, isn't it? So, is there a friction acting on it? No, there is no friction acting on it. So, it implies no friction acts on it, on the box. Friction only acts when there is a relative motion between the two bodies. Okay, friction only acts when one body moves with respect to another one, then only the friction force will act. Okay, if it is not moving with relative to the body, it will not act. So that was basically about the friction force and what is the definition. Okay, the next thing which comes in the friction force is, so there are two kinds of friction. Friction basically we talk about. Okay, one is a static friction and one is a kinetic friction. Okay, so let us go in detail and study about these two. So in friction, basically we can have two types. Firstly, we have static. Okay, and another is, now another name is kinetic. Uh, some people also say it's dynamic. So both of these words are applicable for this. Okay. Now, first of all, let me introduce to you what is static friction. Okay. If you're studying it for the first time, please listen to this very, very carefully. Okay. Static friction is basically what is a friction due to push or pull, friction due to push or pull without causing movement, without causing movement, without causing movement. That is basically if the body is not moving, this friction will act. All right, the value of static friction Fs is less than equal to mu s n. Okay, that it can go up to a maximum value of, so we write Ff max is equals to mu s n. This is a maximum value which is there, but it can also be less than that. Okay, so it varies basically. It is not fixed value, but the maximum is basically this. All right. There is another one which is the dynamic friction now, dynamic or the kinetic. Okay, dynamic or the kinetic friction. Now, what is it? It is a friction due to when the object is moving. Okay, friction. We talk about this friction when object is moving. Object is moving, and its value Fk or Fd is basically you write mu d into n. Now this mu over here, mu s and mu d, which I wrote, are called the coefficients of friction. Okay, and n is the basically n is over here is the normal reaction force. N is a normal reaction force which we discussed earlier. All right, so this is basically the two types of friction. Let me give you a very quick explanation of what exactly the static and dynamic kinetic friction means, right? Suppose, let's say you have a block. If there is a block kept on a rough surface, okay, there is a surface which is rough, okay, mu s for this, okay, before giving the mu s value, let me explain you a bit more on this situation. All right. So it is a rough surface. Rough surface means that there will be friction in this. Okay. Now let us say suppose this is being pushed, okay, or you are pushing by yourself, okay, with some force of let's say 50 newtons. Okay, you are pushing this box with the force of 50 newtons. Now I tell you that you require at least of now to move this at least 70 newton is required. Okay, to move this. Now, will the 50 Newton force will be able to move it? No, it will not be able to move. Okay, now the object implies no movement. If the force is only 50 Newtons, no movement. That is, if there is no movement, what kind of friction is acting? It is static friction right now. Okay, it is static friction which is acting, which is basically backwards. So backward there will be a static friction Fs, and what it will be equal to? It will be equal to 50 only, because the box is not moving. The net force on the box has to be zero. Okay, the box is not moving, so obviously whatever force you are pushing it has this. There is some opposing force which is equal to the 50 Newton, which is basically stopping the box from moving. So the static friction is acting and it will be equal to 70 newtons. Clear? Okay. Now what is this 70 Newton? Which how does this came? This is basically called the Fs max value. That is the minimum value of the force which is required to overcome the friction. Okay. Now this, suppose let's say consider another situation, the same box. Now you are moving. Okay, now suppose let's say for an instant, the force becomes 80 newtons. F, okay, for an instant. Now the force is becoming 80 newtons. Will the box will move? Yes. Now box will move. At that instant, what is the friction? Okay, what is the friction? Now it is kinetic friction which is acting. Okay, so this was basically about what kind of friction will act and how it will act. Okay, now one more thing I want to tell you is that static friction is always greater than the kinetic friction. Okay, this is last point over here. The static friction is always greater than the kinetic friction or the dynamic friction. How this situation comes about, you can just imagine. I think you must have done it by yourself. These cases, suppose you are moving a very heavy block on a floor, okay, which is rough. Okay, now when you move at when you start to move it, okay, some because it takes a lot of force to move it. Suppose let's say, okay, you're pushing it or you're pulling it, but it is not moving. Okay, but you keep on trying it, and you push it with your full limit. Ultimately, starts moving. At, as it starts to move, the force now required will be less. This is the common observation. I think you must have done it by yourself. Okay, as it starts to move, the force required is now less. Why does this happen? Because when the box was not moving, which friction was acting? Static friction. But when the box starts moving, which friction is acting? This is kinetic friction. That's why the force required to move an object when it is already moving, it is less. All right. Okay. So that is basically the idea and how we differentiate static and kinetic friction. Okay, there is little more over it. Okay, when we discuss Newton laws, okay, this and so the questions will be framed combining the Newton laws and the friction. Okay, there's a lot of interesting and very good questions come arises. Okay, so you need to be having a very good and very conceptual knowledge of all of this. So that's it for today's session. We'll stop over here and we'll continue in the next session of the forces. Okay, next lecture. And before going, just please for this kind of seeing this kind of interesting sessions and to do more, because this is like a demo session only. Book your regular classes with us. There will be a lot more in that. You will have plenty of questions to discuss, and then you can even ask your doubts, and your doubts will be resolved in the classes. So do check the website of prepaze.com, and you can have a free trial class. So do have a look at that. So I'll meet you in the next session. All right. Okay. See you. Bye.